video tonight. Convert this to horizontal mill and pull this head off. Machine set up. Switch is on. Ah, there she goes. Okay, well, I've spent a lot of time. This is Jeff from E.D.S. Inc., Shandon, and we're going to be making some gears. This is the first time that this dividing head has been used by me since I bought the machine. I spent most of the evening last night cleaning everything because I haven't ever used this as a horizontal mill. I've always used it as a vertical mill since I purchased it, and so this is the first time I had it set up. So all these supports had to be cleaned. They had started to have a little thin film of rust, and these things are tight the way it is to get them on. I mean, it's just super precise. You have to just perfectly slide those things on anyway, and with that little bit of garbage in there and a little bit of garbage on the ram, it made it for kind of a pain in the rear end. Anyway, but we got it all done. We got everything hooked up. We got our cutting head on. I've got it centered on my piece, and we're ready to start cutting some gears. So we'll get the camera set up there to do that. Again, this is something that I haven't done before. So I've looked at the machinist handbook, and hopefully I've read everything right, and I've got the thinking down correctly on it, and so all we can do is try it. If it works, then great. If it doesn't, I'll start from fresh. Last night we put our part into the lathe, the old Oliver, and we trimmed that up and got it ready. The circumference of the material that I'm using is 1.50, which is exactly what I need. So now it's not perfect. It's aluminum round stock, and it's not going to be a perfect 1.5, but it's close enough for what we're doing. Nothing that I'm doing here is super precise. If we're within a couple of thousandths, we're going to be just tickled pink. So we're going to give it a go and see what happens, and bring you along for the little journey that I have. So I'm going to bring you into the machine. I'm going to talk about the setup and what I've done, and we'll go from there. Okay, so my depth of cut needs to be 0.2696. I've already got the tooling zeroed out on the top of the tool. So we'll go ahead and we'll bring this up. Okay. Okay, so I need 0.26.
Hey, excuse me! on earth is going on here? Oh yeah, sorry, we ran into a snag. You ran into a snag? There's nothing happening!
Hold on just a second, something is happening.
Yeah. Farting noises. Real exciting. Look, I'm sorry. The film must have come out at the wrong time. What do you want me to do about it? Just go to the next scene. Okay. Okay. I'm not paid enough for this. Wait, we're getting paid for this?
So this is the part that I just made. You can see it basically is a gear. Now, what's going to happen is we're going to have a short shaft on the end of this, and this is actually going to be two thin gears. They're going to be fastened to a plate. One with will be set for, you can see this here, this is a hole. That's 1 inch from the edge of the door, and it'll interact with that cam. And the other one will interact with the cam that's on the back side of this, which will be 2 3/4 back set. If you look at this, you can see that the center line right here is 1 inch. So I thought it was 1.5 inches or 1.25 inches, but it's not. It's 1 inch. So I have to move that center line over to 2 3/4. I'll probably do it to 2 1/4 because I have to keep this hole covered. So I have to estimate the width of this trim here from this point to this point, and make sure that when I have it maximum over, it's going to cover this hole, so that hole won't be seen. So so I have to do some math here and figure that all out. Okay, we're doing our final turning on these. I'm first putting a 1/2 inch shaft. It's going to be slightly under a 1/2 inch because the plate that I'm putting it into will be the plate that I'm putting it into will have a 1/2 inch bore. But so we want to make sure that this is at 1/2 inch, or slightly under, maybe a thousandths under. Right now I'm at 0.58, so I've got about 4 thousandths of an inch, 4/100ths of an inch rather, to take out. I may have overshot that. Looks like I got it down to 3/8. Got carried away. That taper in there, I had a hard time. No, it's still 650. Huh? That should do it. And when I trim that off, when I part it, I use the parting tool to clean that up. Let's see, I'm going to have to cut. Oh, hold it. I measured off the wrong spot. That's okay. We'll clean it up with the parting tool. Okay. So I think what I need to do is get a parting tool. We're going to take and trim this back to where it needs to be. Drill a hole down the center of this, and then we'll part the two gears. Well, I'll clean this up and then we'll part the two gears. I'll be right back. Okay, I think that I didn't have the camera going, or that it wasn't focused on the part while I was cutting it. So basically what we have between here and here is a little over 6.5 inches. It's 0.67 something. Okay, back at it here. Sorry about that interruption, but I had to go and talk to a contractor. Okay, so what we have here, this is about 6.7 or 0.679 across. And what we're going to do is split this right in half. This will be two different gears, and they'll be identical on this side and this side. So they'll go into a plate. Well, what I just got off the phone with the contractor, and the cylinder, most exit devices, the motion to unlock the exit device can either be right or left, and on this particular exit device, it's a low-end device. It only turns one way, and he can't remember what way it is. I'm assuming, and assuming gets you into trouble every time, that it's going to be clockwise. But on some of those devices, especially the low-end ones, it would make a difference depending upon the handing of the door. So if it's a left hand, it might be counterclockwise. If it's a right hand, it might be clockwise, or vice versa. At any rate, so it's a good thing that I made extra gear, because I'm going to make another gear here. And when I set up my plate for my gears, I'll have the ability to change the location of the gears, so I have a third cog in order to change the direction of the cam that will be actuating the exit device. So at any rate, it was a good thing that I made this thicker, wider, because I may need 3 instead of 2 gears. So at any rate, I'm going to finish milling this. I've got to mill this part in here down to is 0.49 is what I want, end result, and have a little shoulder on here. So you see what I made? So we're good with that. This. I think what I'll do is I'll wait for this one and cut that after I get it off. I'm going to go ahead and do a center drill. I have to go measure, I'm going to turn you off and I'll bring you back. I have to go take a dimension off of a piece of tailstock, so I know what to cut this to. I'll be right back. Okay, boy. Okay, I forgot one very important part. We have a snap ring going on this, and so I forgot to cut that. I was about ready to cut all the way through here, and then realized I'd never made my slot for the snap ring. I have to make one here and one over here. So so I'm going to go ahead and I should make one right here too, because this will be the face of it. So so I'm going to go ahead and do that. I'm going to make all my slots for my snap rings, and So we'll make the slots for our snap rings. Now I didn't have a tool to do that, so I ended up having to cut a little tool. I had some carbide, a piece of carbide that actually is high-speed steel. I apologize. A high-speed steel that we're going to use to make that slot. And so let's go ahead and we'll get started. Okay, we're back on again. Okay, so this cutter, I had to actually grind that to the proper dimension so that I could cut this slot for the clips. So let's go ahead and we'll get this in. I was having a problem. The tool kept going down at this angle, and the reason is this top bolt wasn't hitting it, so I had to put a flat plate in that would cover that, so I had some downward pressure to prevent it from cocking. Anyway, let's go ahead and we'll get this next slot in. Oh, that was a mistake. That's about where I want it, right there. Oh, she's cutting so much better now. Okay, just by guess and not by measurement, but all three of these are, two here and one here, are totally identical. They're all exactly 0.429, which is pretty near 0.43. So, and that was done by guess and by golly. That was just by feel. But I don't expect to get that close most of the time. So what I have to do now is finish parting this off. So I have to put the parting tool back in there. Part this one off. And once I part this one off, and I'm going to probably have to use this little tool I cut because I hardly have enough room to part that. I mean, there's barely, if I've got 3/16 of an inch, and my cutting tool is, I need a little bit of shoulder for those snap rings. So I'm probably going to use this to part this. So I might as well go ahead and part this one off so I don't have to keep changing tools, and I'll just use this to do so. And then we'll go back to the next one. Okay, so we've got just about what I need as far as gearing left. I need about a 1/4 of an inch of gearing. I'm going to measure this over and find out where I need to be, and then we'll start cutting this down. Okay, I've put a shoulder in there, so I need to check and make sure that I'm at about 625 there. Oh, I got plenty of room, yeah, 7.3. There we go. Okay, what we're going to be doing is we have to make a slot in this for this cam. So that's just a little bit over 2.5. So we're going to go 130 each way. And that should get us what we want. So we're going to go one way. Okay, we've got, I'll use this as a pointer. We've got one of the gears clamped into our vices here, and we're making our slot across. Now, one of the problems that I had, and why this has waited until today to get done, is that the bit that I had in here the other night was not long enough. I'd bottomed out and I'm not through the bottom of the part, and so I went down to one-stop industrial supply, and I was able to get this 1/8 inch bit. It's a little bit bigger in diameter than what I was using, but it's much longer. And this is high-speed steel instead of carbide. I think that we'll probably get better life out of it cutting aluminum, and that it's slightly more flexible. The carbide is so brittle that a lot of times when it hit the shoulder, I broke the carbide. So hopefully this one will hold up a little bit better than what the carbide did, and so we'll be able to complete this. We have this one and one other one to do, get completed as far as the slot goes, and I need to surface, like I did this one, I need to surface the top of this one here. So I don't know if you can see it or not. I'm not into, but this sprocket here, I'm going to need to surface down. It's a little bit thick, and so I'm going to need to surface that down. I hate to ruin that pretty face on it because the mill doesn't do that pretty of a job, but we're going to go ahead and resurface this to the same thickness as the other two gears. Okay then, so we're going to go ahead and finish this slot out through the bottom of this thing, and then we'll put the other part in and do exactly the same thing. Well, before we do so, I'm going to take you off camera because I've forgotten I need to put some oil in the machine. So we're going to take a break for a second. I'm going to make sure that the machine is well oiled and greased, and then we'll come back to it. Okay, so we've gotten our hole drilled in this, as you can see, and I blew it. I'm dead centered. I should have measured it instead of a guess by golly. I didn't measure it, and that's what I get. But that's okay. It's, like I said, it's not super critical. The reason for the slot is this is the driver that runs through this, and that'll run through this. This is actually a short one. And the long one will run 2 inches, so it'll run through the cog all the way into the other door, and then when this cog is turned, it'll unlatch the exit device. So at any rate, I still have another slot to do on another cam, or gear rather, and then once we get that done, we can start developing the plate, laying out the dimensions for where these things go in the plate and get that done. There we go. Our 3 cogs. Well, those will work. This should probably clean up these ends too. This one here's got a little bit of a burr on it. So I may just put them back in there, reset the height on this, and just top these off, clean them all up. Hello, this is Jeff Urban, E.D.S. Inc., Shandon, and to first start off I want to apologize for this video in that while I was doing the machining of the gears, apparently I had some mishaps with the camera, got shut off. I'm not sure exactly what happened, but you missed most of the machining that took place. Poor performance on my part, sorry about that, but some may wonder how did I come up with the sizes and that sort of thing of my gearing. And it's really on the basis of what I had. So I had an interlude cutter, a number 8, and so I based everything on that number 8 cutter, interlude cutter, and then I went to my machinist handbook and I looked up some important aspects of that. Now we're going to talk about that, and I'll show you how I came up with the diameter of my stock and the number of teeth per gear and how I got that ratio right. And this may not be a professional way. I'm not a genius on this stuff, but this is the way I did it, and I'll kind of explain it to you as I go. So hang on for a second and we'll get the camera up on the blackboard here and I'll show you what I'm doing. So forgive my rudimentary drawing here. So basically the way that I came up with this, as I mentioned, I had a cutter. It was a number 8. It is an 8-pitch cutter. And so the first thing I went to is my machinist handbook, and I looked at what I could do with the number 8 cutter, and finding that the cutter could cut 10 teeth. I found out what the pitch diameter would need to be for that, and with 10 teeth with a number 8 involute cutter, the pitch diameter would be 1.25. Now there's some other interesting things that you can determine here from the machinist's handbook. One of them gives you the dimensions for that number 8 pitch cutter, the different parts of the tooth from this line. So above this line to the top of that cutter is called the addendum, and that is 0.125 with this particular, with 10 teeth, 10 tooth cut. The addendum, which is below this line to the bottom of the cut, is 0.1446. So to determine what the outside diameter of my stock needed to be, I took the pitch diameter of 1.25 and I added 0.125. So that's basically 1 3/8 of an inch. So that was my outside diameter of my stock that I needed. So then, to determine the depth of cut, I took the addendum number and the dedendum number, and I added those two together. So that comes to 0.2696. 0.2696 of cut, a little bit over 1/4 of an inch from here to here. So then I milled my stock down to the proper outside diameter. I then set it up in my dividing head, and my dividing head is for every 40 turns you have one 360-degree turn. So it was that was a real basic, easy mathematical formula. To get the right divisions between teeth, all I had to do is make 4 rotations, 360-degree rotations of the handle on the dividing head, and I would split this circumference into 10 places, 10 cuts. That's what I did, and that's how it turned out. And everything turned out really sweet with those gears there. The dimensions came out perfectly. They worked perfectly together. Now this pitch diameter is really the working diameter of the gears. That's where they mesh together, and that's where the power comes from in the gear. In fact, I changed my book. I was going to read you the definition of that, but I went and turned my book, so I don't have that up front. But anyway, that helps to explain how I came up with the outside diameter of my piece. You use the machinist's handbook, you use the cutter that you have, and the number of teeth that you're going to be cutting with that cutter, and you're able to come up with your pitch diameter, and that number 8 has an addendum and a dedendum. And so then you know what your depth of cut needs to be. Now, of course, I didn't have to be that close with this. If you were actually transferring power, I was just transferring motion. I just wanted to move the motion from one point to another. But if you were actually transferring some sort of power, number one, you wouldn't use aluminum like I did. You'd use a better grade material, but you would have to also have much closer tolerances than I had to deal with when I was working with these gears to have the gears operate properly. But all in all, it turned out real well. I never measured the gears to see if I hit my marks. I used my DRO, found my zeros, and went from there. So I wasn't super persnickety. Once I made my cut, I made my passes for each tooth. I just made one pass. I was cutting aluminum, and I cut it full depth. And then would just back my head off turn the shaft and do my next cut. So that's pretty much how I did it. I don't know how much of that got on film. My son just told me that a lot of the milling part of it disappeared or wasn't there, or I was looking at the floor or something like that. I don't know, but hopefully that explains how I came about with the diameters, the quantity of teeth, all that sort of thing. Really, an invaluable tool is the Machinery's Handbook. That really gives you a lot of help in determining those things and coming out with a successful project. So we'll sign off for now. Thank you for watching E.D.S. Inc. Shandon. If you like the content, please subscribe.